Now we're going to cover Rolles Theorem, or Rolles Theorem. Um, Rolles was a French mathematician, and there's a bit of controversy behind how he got into calculus. He actually didn't agree with it to start with, so this is really exciting that he was converted over. Feel free to do a little research on him. He's really fascinating. Let's go back before we get into his theorem, and let's look at two graphs. Now, you remember we could have relative maximums. In the first case, we have a relative maximum when f is continuous and it's differentiable. And we can also have a maximum if it's continuous but not differentiable. We are going to focus on this first type here with Rolles Theorem. Now, please write this down in your notebook and have this memorized. Rolles Theorem says if f is continuous on a closed interval between a and b, and differentiable on the open interval, and if fa equals fb, then there has to be at least one number c that is in a and b, such that the derivative of the function evaluated at c is equal to 0. Let's think about what this means. Quite literally, what it means is there's got to be a relative max or a relative min if the function is continuous on a closed interval and differentiable on the open interval. So it's going to be continuous on closed and differentiable on open. That's CC and DO, so you can remember those. And if the function has the same value at two different points, then there has to be a max or a min. Now, this was really exciting news in calculus. I know you're not all that thrilled about it. Let's look at what happens if we're dealing with a function that is a straight line. All right. If f of c, if fx is some constant c throughout the entire interval, it is continuous on the closed interval and it's differentiable on the open interval, of course. It's a nice little straight line. We're going to carry it on. All right, and clearly f of a equals f of b at a point. This one is kind of a trivial case because the derivative is 0, the slope is 0. What if we don't look at the trivial case? What if we look at the case where we have some sort of curve? All right, and I'm going to switch colors here. F of a equal f of b. Let's just call that a D, since that's what my graph here says. And let's suppose we've got this situation right here, so that f is greater than d for some x in this area, or in this interval. Now, by the extreme value theorem, you remember, we know that f has a maximum at c in this interval. And since f of c is greater than d, we know that it does not occur at an endpoint. Okay, because we don't have that equal sign. So we know we're going to exclude the endpoints there. So, therefore, f has a maximum on the open interval. All right, this also implies that f of c is a relative maximum. Why? Well, remember the theorem we did last time? It's 3.2 in our book that says that if f has a relative max or min at c, then c is a critical number. All right, so we know that c is a critical number. All right, and finally, since f is differentiable at this point, therefore we know that f prime has to be 0. Now that's a tremendous amount of work. Please memorize it and be able to apply it, which is what we're going to do from here on. Now, determine whether Rolles' theorem can be applied to the function, and if it can, let's find all values from which f prime is 0. Now, can it be applied? Well, I have to show that f is continuous on the closed interval 1, 3. Now, since f is continuous for all reals, then yes, this is true. Next, we have to show that f is differentiable on the open interval. And in fact, that is true as well because it's a polynomial. Now find all values such that the derivative is equal to 0. A couple ways we can do this. The first way, we could use the product rule, but let's just go on and multiply this out. Let's see, this first one is what? X squared minus 3x plus 2 times x minus 3. Now let's multiply this out. This is x cubed minus 3x squared minus 3x squared plus 9x plus 2x minus 6. Collect terms. X cubed minus 6x squared plus 11x minus 6. So f prime at c is 3x squared minus 12x plus 11. Now to find the points, just apply the quadratic formula. So, I guess it should be x. The x's are plus 12 plus or minus the square root of negative 12 squared minus 4 times 3 times 11 all over 2 times 3. Now this is ugly. I'm not going to kid you, this is ugly. So this is 12 plus and minus the square root of 144. Let's see. 4 times 3 is 12. Okay, 12, whoops, clear. 12 times 11 is 132. All over 6. Whoa, sorry about that. So it's minus 12 plus or minus the square root of, 144 minus, God, that's a mess. Let me erase that. I don't like things messy. All right, so this is pen. Sorry. So this is 12 plus or minus the square root of 12 divided by 6. And that's good enough. Your turn. Stop the tape. Turn it back on when you're done. Now, let's do some illustrating. Suppose I'm given the function f of x is x squared minus 3x plus 2. I want to find the two intercepts and show that the derivative is 0 between 2 points. Okay, how do I find intercepts? Intercepts are easy. I just take function and set it equals 0. So where is x squared minus 3x plus 2 equal to 0? Let's see, let me factor this. I need two numbers that multiply to be 2 and add to be negative 3. And that's, of course, going to be x is negative 2 and x minus 1. So my zeros are when x minus 2 is 0 or x equals 2. Erase that. All right. Or when x minus 1 is 0 or x equals 1. So I found the two intercepts and show that f prime is 0 somewhere between. Well, let's find f prime. So that is 2x minus 3, and that equals 0 when x is 3 halves. And lo and behold, 1 is less than 3/2 is less than 2. It's between, not equal. Your turn. Stop the tape. Turn the tape back on when you're done. We've got one more example. Now, for this one, we want to find all values of c on the interval -2 to 2 such that the derivative of c is 0. All right, well, this is straightforward. Let's just take the derivative. F prime is 4x cubed minus 4x. Now, where are these 0? Well, this is 0. I'm going to factor it. 4x times x squared minus 1. I can factor a little bit more, can't I? So this is 4x. I thought I was going to have to use quadratic formula. X minus 1, x plus 1 equals 0. So, where are my zeros? They're at x equals 0, x equals 1, x equals -1. And let's see, that is pretty much lining up with my graph. It's always cool when that works. Now, your turn. Put this one in your notebook. When you're done, finish the rest of your homework.